Download this code from codegive.com, link in the description below. OK, buckle up. This will be a deep dive into 7 advanced ABAP concepts, background jobs, and debugging, all intertwined, with a focus on using the jdbg debugger and providing code examples. This is a lengthy and comprehensive guide, so feel free to jump to sections that are most relevant to your needs. I7 Advanced ABAP Concepts. We'll be exploring these 7 concepts in detail, focusing on their relevance to background processing and debugging. 1. Shared memory objects asterisk. 2. ABAP channels asterisk. 3. Object-oriented programming, OOP, with ABAP asterisk. 4. Dynamic programming asterisk. 5. ABAP managed database procedures, AMDP. 6. Asynchronous RFC, ARFC, and qrfc, qrfc. 7. Parallel processing asterisk. 1. Shared memory objects asterisk asterisk. Asterisk concept asterisk shared memory objects allow different ABAP sessions, including background jobs, to access the same data in memory. This reduces database load and improves performance, especially for read-only or frequently accessed data. Asterisk relevance to background jobs asterisk background jobs can load data into shared memory, which other jobs or dialog sessions can then quickly access. This is useful for caching data used in multiple reports or processes. Asterisk debugging implications asterisk when debugging, you can inspect the contents of the shared memory object to understand the data being shared between different processes. This helps identify data inconsistencies or unexpected modifications. Asterisk code example asterisk. Asterisk explanation asterisk. Asterisk ZCL underscore shared underscore memory underscore example is a class that manages the shared memory area. Asterisk define underscore area creates or retrieves the shared memory area named ZSHM underscore example. Asterisk set underscore data binds the provided data to the shared memory area. Asterisk get underscore data retrieves the data from the shared memory area. It's crucial to attach and detach to the area. Asterisk the submit underscore job form demonstrates how to submit a background job that uses the shared memory. One job sets the value, and another, or a dialog process, can retrieve it. The program passes parameters p underscore action and p underscore value to decide if data is read or set to shared memory. Asterisk debugging asterisk use transaction SHMA to view and manage shared memory areas. In the debugger, jdbg or classic debugger, you can inspect the contents of go underscore area and gv underscore data within the class to see the data being shared. Set breakpoints in both the setting and getting processes to observe data flow. 2. ABAP channels asterisk asterisk. Asterisk concept asterisk ABAP channels provide a mechanism for real-time communication between ABAP sessions. There are 2 types. Asterisk push channels asterisk allow the server to push data to clients, example browser-based applications. Asterisk messaging channels asterisk enable bidirectional communication between ABAP sessions. Asterisk relevance to background jobs asterisk background jobs can use messaging channels to notify other processes, example dialog sessions or other background jobs, about their progress or completion. This allows for real-time updates in user interfaces or triggers for subsequent processes. Asterisk debugging implications asterisk debugging ABAP channels involves understanding the flow of messages between sessions. The debugger can be used to inspect the messages being sent and received, as well as the state of the channel connections. Asterisk code example, messaging channel, simplified. Asterisk explanation asterisk. This simplified example demonstrates sending and receiving messages on a channel named my_channel. Important a full implementation requires a message listener, which continuously listens for messages on the channel. This example is for demonstration purposes within the same ABAP session. *send_message creates a message handler, sets the message text, and sends it. *receive_message retrieves messages from the channel. Again, this is a simplified example and only useful in the same session for demo. To use with background jobs, you would need a separate ABAP program, likely a class implementing if_ABAP_message_consumer, acting as a listener that the background job can notify the background job would send the message, and the listener would process it. *debugging debugging ABAP channels effectively in a real scenario, background job to listener, is tricky. You'll need to debug both the sender, background job, and the receiver, listener program, separately. Set breakpoints in both to track the message flow. Examine the parameters passed to the send and receive_messages methods. Use the jdbg debugger's features, as described later, to monitor variables and step through the code in both processes. 3. Object-oriented programming, OOP, with ABAP ***. Concept *OOP principles, encapsulation, inheritance, polymorphism, promote modularity, reusability, and maintainability of code. Relevance to background jobs use classes to encapsulate the logic for background jobs. This makes the code easier to test and maintain. Inheritance can be used to create specialized background job classes from a base class. Debugging implications OOP code can be more complex to debug due to the interactions between objects. The debugger allows you to inspect the state of objects, step into methods, and trace the call stack. Code example explanation *ZCL_background_job_base is an abstract base class for background jobs. It defines a common interface, execute, get_status. *ZCL_specific_job inherits from the base class and implements the execute method with specific logic. The submit to job statement is used to schedule the execution of the job. Programs program_execute_job is used to execute the job. It receives an object reference p_job_object as a parameter. Debugging set breakpoints in the constructor and execute methods of both classes. Use the debugger's ability to inspect object attributes, example mv_status, mv_param. Step into methods to trace the execution flow. Pay attention to the inheritance relationship and how the methods are being called. Debugs program_execute_job both in the dialog and in the background to ensure the object is passed correctly. 4. Dynamic programming concept dynamic programming involves writing code that can adapt to different data types, structures, or program logic at runtime. This can be achieved through techniques like field symbols, data references, and dynamic method calls. Relevance to background jobs dynamic programming can be useful when you need to process different types of data in a background job without hard-coding the data structures. For example, you might need to load data from different tables based on a configuration setting. Debugging implications debugging dynamic code can be challenging because the exact code being executed is not known until runtime. The debugger allows you to inspect the values of field symbols and data references to understand the data structures being used. Code example Asterisk explanation asterisk. Asterisk this example dynamically selects data from a table specified by the user, parameter p_table. Asterisk create data gt_data like table of p_table, creates a dynamic internal table based on the table name entered. Asterisk assign gt_data to fs_data assigns the dynamic internal table to the field symbol. Asterisk select asterisk from p_table into table fs_data selects data into the dynamic internal table. Asterisk the loop accesses fields dynamically using field symbols. Asterisk debugging asterisk this code is crucial to debug. Set a breakpoint after the create data statement. In the debugger. Asterisk inspect the value of p_table. Asterisk examine the type and structure of gt_data. The debugger will show you the structure that was dynamically created. Asterisk step through the select statement to see if the data is being retrieved correctly. Asterisk in the loop, inspect the field symbol fs_record to see the values of each field in the record. Use the display structure button in the debugger to examine the record's fields. 5. ABAP Managed Database Procedures, AMDP. Asterisk concept asterisk AMDP allows you to write database procedures in ABAP using SQL script and execute them directly in the database. This can significantly improve performance for data-intensive operations. Asterisk relevance to background jobs asterisk AMDP can be used to perform complex data transformations or calculations in the database within a background job, reducing the load on the ABAP server. Asterisk debugging implications asterisk debugging AMDP involves debugging the SQL script code within the database. You can use the SAP HANA Studio or the ABAP debugger to step through the SQL script code and inspect the data being processed. You can set breakpoints in the ABAP code that calls the AMDP method. In newer versions of SAP, you might also have the ability to debug the SQL script directly. Asterisk code example asterisk. Asterisk explanation asterisk. Asterisk the get_sales_data_impl method is an AMDP method, indicated by the by database procedure for HDB clause. Asterisk it uses SQL script to select data directly from the SFLY table. Asterisk the select statement is executed within the SAP HANA database. Asterisk the get_sales_data method calls the AMDP method. Asterisk debugging asterisk. Asterisk set a breakpoint before the call to zcl_amp_ example equals get_sales_data. Step into the method. Asterisk you can't directly step into the SQL script code from the ABAP debugger. Asterisk to debug the SQL script asterisk. 1. Use SAP HANA Studio, or SAP Web IDE for HANA. 2. Set breakpoints in the SQL script code within the get_sales_data_impl method. 3. Run the ABAP program. When the AMDP method is called, the breakpoints in HANA Studio will be triggered. 4. Alternatively, use truncate to break into the SQL script debugger. Asterisk in the ABAP debugger, examine the contents of LT_sales after the call to get_sales_data to verify the data is being retrieved correctly. Asterisk check the return code sy_subrc after the method call to ensure there were no errors. Asterisk important asterisk ensure that your ABAP user has the necessary database privileges to execute the SQL script code. 6. Asynchronous RFC, ARFC, and qrfc, QRFC. Asterisk concept asterisk. Asterisk ARFC asterisk allows you to call a function module in a separate ABAP session without waiting for the result. The calling program continues processing. qrfc guarantees that function modules are executed in a specific order. It uses queues to manage the order of execution. Relevance to background jobs. ARFC is useful for triggering background jobs from other processes without blocking the calling process. qrfc is useful when you need to ensure that background jobs are executed in a specific sequence, such as processing financial transactions in the correct order. Debugging implications. Debugging ARFC and qrfc involves monitoring the execution of the called function modules in the separate sessions. You can use transaction SM58, transactional RFC monitor, and SMQ1/SMQ2, queue monitor, to view the status of the RFC calls and the contents of the queues. Code example, ARFC. Explanation. Call function. Starting new task. Destination in background task is the key to ARFC. Destination in background task makes the call asynchronous. It creates a new background process to execute the function module z_background_job_fm. The calling program continues immediately after submitting the ARFC. The performing return_data on end of task is optional. It defines a form that will be executed when the asynchronous call is complete. However, due to the nature of asynchronous calls and the separate context of the called function module, it might not always execute as expected or be easily debugged in all scenarios. Therefore, it's often better to rely on the SM58 transaction for monitoring purposes. z_background_job_fm is a regular function module that will be executed in the background. Debugging. 1. Set a breakpoint before the call function. Starting new task. Step through the call and note the task name assigned to the asynchronous task. 2. Immediately after the call function, the calling program will continue. 3. To debug the background process. Go to transaction SM58. Find the RFC entry corresponding to your task name. The status will likely be transaction recorded. Select the RFC entry and choose Execute LUW. This will trigger the execution of the function module in the background now. You can then debug the function module z_background_job_fm using the standard ABAP debugger. Set a breakpoint at the beginning of the function module. If the SM58 execution triggers a new session, the debugger will open in that session. 4. If the return_data form has run, you can also debug this section of the program. Note that this needs to run in the same LUW as the initial call, so any errors in the return data can prevent the function module from completing. 5. Important *. The debugger in SM58 is crucial for understanding the execution of ARFC calls. Pay attention to the status of the RFC calls and any error messages. QRFC, illustrative concepts, code omitted for brevity. Key functions. TRFC_set_q_name, assigns a queue name to the RFC call. Call function. In background unit, used instead of starting new task for qrfc. Debugging. Use transactions SMQ1, outbound queue, and SMQ2, inbound queue, to monitor the queues. Set breakpoints in the function modules being called via qrfc. In SMQ1 or SMQ2, you can select a queue entry and choose Debug to debug the function module. 7. Parallel processing. Concept divides a large task into smaller subtasks that can be executed concurrently on multiple application servers. This can significantly reduce the overall processing time. Asterisk relevance to background jobs. Asterisk parallel processing is ideal for background jobs that need to process large volumes of data. Asterisk debugging implications. Asterisk debugging parallel processing involves monitoring the execution of the subtasks on different application servers. The debugger allows you to inspect the status of the subtasks and identify any bottlenecks or errors. Asterisk code example. Asterisk explanation. Asterisk perform process underscore data in parallel task starts a parallel task. Asterisk the data is divided into chunks. The logic calculates the start and end indices for each chunk. Asterisk perform process underscore chunk in parallel starting new task. Task name unit LV underscore chunk starts a new task for each chunk, using the unit clause to load balance. Asterisk wait until all tasks completed. Waits for all parallel tasks to finish before continuing. Important asterisk without this, the calling program would continue before the parallel tasks complete, which is usually not what you want. Asterisk process underscore chunk performs some processing on the data chunk, in this case, calculating a sum. Asterisk debugging. Asterisk 1. Set a breakpoint before perform process underscore data in parallel task. Step through the call. 2. Set a breakpoint at the beginning of form process underscore chunk. This will be triggered multiple times, once for each parallel task. 3. Monitoring parallel tasks. Asterisk transaction SM50, work process overview, is crucial. You can see the different work processes running on different application servers. As the parallel tasks are executed, you'll see them appear and disappear in SM50. Asterisk you can select a work process and choose program-debugging to debug the code being executed in that work process. However, this can be tricky because the work processes are assigned dynamically. Asterisk the task name can be used to filter the processes to assist with debugging. 2. Background jobs, a more detailed look. Asterisk core concepts. Asterisk job definition. Asterisk defining the steps, programs, reports, function modules, that will be executed in the job. Asterisk job scheduling. Asterisk setting the start date, time, and frequency of the job. Asterisk job monitoring. Asterisk tracking the status of the job and viewing its logs. Asterisk transactions. Asterisk SM36, define background job. Create a new job, add steps, and schedule it. Asterisk SM37, background job selection. Monitor existing jobs, view their status, and access their logs. Asterisk SM50, work process overview. Monitor work processes and debug background jobs in real time. Asterisk ST22, ABAP dump analysis. Analyze ABAP dumps that occur during background job execution. Asterisk SLG1, application log. View application logs written by background jobs. Asterisk key function modules. Asterisk job underscore open, opens a background job for definition. Asterisk job underscore submit, adds a step to the job, example submitting a report or program. Asterisk job underscore close, closes the job and schedules it for execution. Asterisk BP underscore job underscore read, reads information about a background job. Asterisk BP underscore job underscore status underscore read, reads the status of a background job. Asterisk example, scheduling a background job, more detailed. ABAP. Report Z underscore background underscore job underscore example. Parameters, P underscore repeat type SY repeat obligatory. Report to execute. Parameters, P underscore param type string. Parameter for the report. Start of selection. Perform schedule underscore job using p underscore rapid p underscore param. Form schedule underscore job using I underscore rapid type sy rapid I underscore param type string. Data, lv underscore job name typed job. lv underscore job count typed job. lt underscore params type table of rsparams. ls underscore params type rsparams. Call function job underscore open. Exporting. Job name equals z underscore dynamic underscore report underscore job, give it a meaningful name. Importing. Job count equals lv underscore job count. Exceptions. Others equals 1. If sy subarc equals 0. Prepare parameters for the submitted report. ls underscore param cell name equals p underscore input. Replace with the actual parameter name in your report. ls underscore params kind equals p. Parameter. ls underscore params sign equals I. Include. ls underscore params option equals eq. Equal. ls underscore params low equals I underscore param. Parameter value. Append ls underscore params to lt underscore params. Submit, I underscore rapid, dynamic report name. With selection table lt underscore params pass parameters. To job lv underscore job count. And return. Call function job underscore close. Exporting. Job name equals z underscore dynamic underscore report underscore job. Job count equals lv underscore job count. Stratumd equals ABAP underscore false. Don't start immediately, schedule it. SDLSTRTDT equals SY datum schedule.